So I have some questions, and we've probably already talked about them. So my first question I think we've talked about, but see if you have anything to add, is did you see evidence of students building or developing their ability to make logical or convincing arguments?
I mean, I was going to piggyback off of what you were saying in terms of they were able to use a lot of mathematical reasoning in terms of ratios and proportions, but I didn't hear a lot of ratio and proportion vocab coming out at all. And so that's one of my concerns, is how we deliver a problem. These are very fifth grade friendly, and my fear is on a standardized test, if they're asked, solve this ratio or proportion, and they're given that vocab, if they're not exposed to that over and over and over and in the discussion, and if they're not exposed to that, then they're not going to correctly answer that problem, or they're not going to understand what that problem's asking unless in that discussion those vocab words are encouraged and really brought out over and over. I think that's one thing that could be improved upon, I guess, is really stressing the mathematical vocab so these kids are exposed to that in terms of standardized testing and different ways of delivering the problem or the question.
Okay, so this is just a thing that you might want to explore as a staff, because I know a lot of the lesson study teams have been working with that idea. So I've heard one person throw out the hypothesis that when you're learning an idea, you need to be able to talk about it in everyday language, because you're busy trying to do the sense making, and then the vocabulary comes later. And I know some lesson study groups have said, well, we think you have to have a firm grasp of the vocabulary before you can start struggling with the idea. So it will be a good question to sort of pose for yourself to design a lesson and try that in a couple of different ways.
And test how you deliver a lesson to accurately assess their knowledge.
Yeah, so that's something to think about.
You were on the wrong side of the room. I did hear discussion with students. They were using the math vocabulary, which I was surprised at, actually. And I think you said you did too, with Kevin, and I don't remember the other student that was with him, with the cream and the chocolate again. He's saying it's a ratio. And I don't think the other student really understood it first, but by the time the conversation finished, I think he did. And he set it up for it, 1 to 2, 2 to 4, 3 to 6. And he went on to explain that the student needed to stop there because 3 plus 6 equals the 9. But he also had an explanation of why he went on to 4 to 8, because he was trying to get to 9. But there was no way he'd get to 9 making that type of ratio. Nice. So I think the vocabulary is there, maybe not throughout the whole
We're on
class.
that. We just finished that chapter,
so
it's fresh in their mind.
And I saw one student, as soon as I saw the question on the board, he translate the sentence into ratio first.
Well, I've always been interested in, understanding just the vocabulary of a question. And that chocolate and cream one, it says he first put in 1 cup of cream, and then he added 2 cups of chocolate, and then it goes on to say, well, he had 9 cups in all. But it doesn't directly say that he's always following a ratio. And one of the child that was explaining why one of the other answers didn't make sense kept saying he didn't understand. Look at it, says for each cup of cream there are 2 cups of chocolate, and he kept repeating that, and yet the question's right in front of him, and it actually doesn't say that, but he read it into it, and there's always hidden assumptions in the language, and he just saw that ratio, like that ratio assumption was just really blatant to him, and I think that's interesting.
Yeah, and I think one of the students during the big discussion came up with the idea of serving size, and then he went on to define it as 1 cup of cream for every 2 cups of chocolate, which was a really nice way of putting that into sort of a formal mathematical language, and then thinking about for every group or serving size. But just that idea of coming up with your own definition is a very big, think like a mathematician. Make your definition. I'm going to define this as a serving size, and then I need 3 serving sizes to get to 9. So, good.